Hello. So, give me 1 second. I am going to make sure everything is set up. For some reason, one sec. I'm trying to find chat. I think this should work. So we're going to be reviewing 1153's robot. Yep. All right. This works. So we're going to be reviewing 1153's robot, and then we'll be looking at 112's robot. And I'll be primarily focusing on just design practices, and I'll do a little bit about CAD, but not as much. But yeah, so I guess we can just start with this robot. So we can see we have like a high pivot arm with the telescope, and then we have uh just like an Everybot style-ish double roller intake, or the double roller. I don't think it's Everybot style, but it's close enough. Whatever. Uh, I guess the main things that like going through the LCatch is I'm not like a fan of this polycarbonate structure for superstructure. Would like to see gussets here. I don't know how to feel about. I guess this works if you can cut the corners on the box tube, then it works. But if you're using pre-patterned box tube, it's fine to cut it flat and just use gussets here. Um, just because your strength will come from the gussets anyway. Sim over here would like a gusset here. I assume you just did it in real life, unless you're just using the really thin poly. But this is like 1/16th. Yeah, that's way too thin. Uh, but yeah. Uh, so this is fine. I would like triangles here instead of a square gusset because you get a little bit more strength, especially between the two superstructure beams. Is this ½ inch? Yeah, I would also like to have this dead axle a lot larger. Oh, I see. That explains it. I see. Yeah. Yeah, try to avoid welding. It's not great. For some reason, I can't see chat. Chat doesn't pop up on my thing, which is unlucky. I see. Yeah, that's rough. So you didn't know what a dead axle was. Yeah, I can see that. So, if you check my arm guide, and I assume you already know what a dead axle is now, but what's the point of using churros for this sprocket connection? Oh, everything's just welded? I see. Oh. You had a lot of churro. I see. So, yeah, I would probably just do a spacer here instead of the churro. And same with like over here, I just run spacers. So like I looked through it a little bit earlier, and there's a lot of just like extra manufacturing steps that you don't like need. So like uh here, I think you're using Thunderhex here. You could probably just get away with just a spacer of a through bolt, and that's just less manufacturing steps. And generally speaking, yeah, you'll end up what will happen a lot is there's a lot of these small things. So like manufacture like instead of using Thunderhex using spacers here, or like using I guess like pattern box tube plus gussets here or whatever. But a lot of these like small steps that are a bunch of like tiny manufacturing steps, so it doesn't seem that bad. But when you add everything up over a long period of time, right? Like over a build season, then it like extends your manufacturing steps by a lot. So that means that your robot might be done later, and that's not great, especially when you need drive practice or programming. I guess once we're looking at the arm, let's look at the power transmission for the arm. So it's good that you kept the gearboxes and Neos down low for center of gravity purposes, I assume. I'm surprised. I would have just direct driven the hex shaft here. Like so each of the max planetaries have a hex bore, so you can just put the hex between the two hex bores without like retaining anything. And that would simplify this whole entire superstructure if you did that. And then another thing that I noticed is you have a whole wall of stripped gears because of that. I see. Yeah. Yeah, this is certainly an interesting setup. So I assume we go from the chain setup here to the chain here. Is this 25 or 35 chain? I can't eyeball it. That is 35 chain. That is also kind of heavy. That might have out of curiosity, what is the purpose of this sprocket right here? 2x 35 chain so the arm wouldn't break. Yeah, that arm, I don't think the chain would break, but I assume something else would break. Like this. Or yeah. I mean, I guess it works. But if you're running 35 chain, typically with an FRC, you can get away with 135 chain and for anything. And then if you want to use 25 chain for higher load, you'd use 225 chain. And that like rule of thumb will work for basically everything. I don't think I can think of something out of the top of my head that requires a double 35 chain. Does 2910's robot even... I'm pretty sure 2910's robot only uses a single 35 chain. What the flip? Okay, hello, how long is my name fan? Okay, welcome to the stream. Check Discord. Oh, I see. So if it goes down, it interferes with the chain. I see. Yeah, so how I did the setup on this arm, which I also designed a similar arm style. I would have probably just had the max planetaries further in the back, just for center of gravity purposes, and so it doesn't like hit, as you see here. I assume you used a turnbuckle on the backside, and if you use a turnbuckle, it's fine. Though you'd have to use double. So what is my opinion on printing parts? Which parts specifically? Yeah, I've used Spartan, that's fine, yeah. Just in general, so for 3D printing, I like doing 3D printing for like pulleys specifically, like pulleys with inserts. Stuff like radio holder as well. Ah, I see. Yeah, we broke a lot of inline. Though we did a bunch of curse stuff with the inline, so they broke that way too. It works as a mechanical fuse though, so if you take it that way, then the inlines are good. But I think West Coast products like buff the inlines, so they're a lot stronger now. So in theory, the inlines are better now. But yeah, I just like printing. So I usually do like big spacers. I'll pull up some Sushi God. 1 second. So since I designed a similar robot to that architecture, I should be able to find it. 1 second here. Yeah. I guess while I'm waiting for that to load and arm stuff besides, yeah, I see where the arm architecture came from. Main things, make sure you CAD fasteners here. I see there's like, oh, there's a singular fastener here. But make sure you CAD all like your bolts and nuts. You don't need to CAD rivets because rivets are really annoying to CAD. But especially when you're doing things like arms or when there's a bunch of objects that are moving next to each other, you kind of just want to make sure that you're always designing with your fasteners so nothing like accidentally interferes. And if you start doing stuff that's like a lot more complex, right? It's like then you're gonna get punished if your bolts are just interfering in the if your bolts don't exist. So like here, you can see it's really tight, and if you have a bolt here, it might hit. But this is how I ran the power transmission. So it's just big sprocket, 35 chain going down, and then these two are connected. This doesn't actually exist in yeah, these don't actually exist in real life, but you get the idea. And then we just used some shaft collars to hold it, and it worked fine all season. Let's go back here. Yeah, I would generally avoid welding because that's more steps that takes time. I know like Poofs does welding, but it's like for most teams it's not really worth. For this encoder setup, I can't. Is this 1-to-1? Wait, I don't want to do math. Or was that just encoder? I can't tell if this is 1-to-1. Was it 1-to-1 for you, or this goes small to big with the top of the arm? Okay, cool. I guess that works. Yeah, it's a little cursed, but if it works, it works. What's the best way to design for welding if needed? I probably would ask someone from Poops. I don't think I'm the person to ask. From what I've heard, you basically CAD it as if there's gussets, and then you gusset plus weld it. So you double it. Usually. That's what I've heard though. So I don't think I'm not qualified to give that advice. But from what I've heard, it's gusset plus weld. But yeah, I ran a belt encoder instead of a gear encoder, but gear encoder works. Usually most people do like more 3D printed gears for this because it's low, and the herringbore ones work as well. So you don't need to run the metal gears here. So I guess back to this special dead axle setup to the robot list. Wait, what do you mean by the robot list? I have no clue how long the stream delay is actually. Oh, you posted the. I do not see a non-shape link. Just send it in Discord and I can figure out what to do with it. For some reason, like links don't like go through in chat, and I can't figure out why, and I don't want to figure it out. I guess over here, I guess we'll talk a little bit about this. I would use a larger axle here. So typically with your axle size, oh, it's in bot spam. Cool. I'll take a look at this as well. Cool. So with your axle size, generally you want a larger axle. So it's like, okay, so if we have a small one, all your strength is based on the diameter of the axle. So any of the material inside tends to not really actually have any strength. So that's why you generally, there's a bunch of math related, but in very short, tube is generally good. And as the axle gets bigger, it's also good. So max spline is really popular as a dead axle choice. You can also do like, I think 7/8 tube is the other popular option because the bushing fits into a bearing hole. And either way, other things is it was solid but not actually, yeah, it would bend. That makes sense. Yeah. Another thing I would do is I would avoid using bearings at all in high load. Like I think the bearings might work, but generally if you're being safe, just use bushings. Yeah, over the summer. That makes sense. Cool. I assume you continue using churros here, or did you switch to like a spacer setup here? I would have probably done just one spacer here instead of the whole churro setup, because that sounds like a bunch of manufacturing steps. But the whole churro thing probably is okay. It's just a lot of work that you probably don't need, I think. Out of curiosity, how did you make your rack and pinion? It was always 4 axles, just got changed to steel hex. I see. You just bought it from McMaster? I see. I mean, the rack and pinion works. I see. Yeah, if it works, it works. I can't really say anything. It might be a little bit heavy, but it's whatever. I think the main thing. Did he have any issues with the rack and pinion with the Neo, or? Yeah, it's just heavy. That makes sense. I think typically teams run like a belt run here. These belts are usually a lot lighter. You can just run a belt with the. Oh, burnt out because it jammed. Yeah, Neo 550s did that. Yeah, if I were to redesign it, I would do a belt run here, and then. Oh, this is. I assume this is the hard stop. So there's a sensor here. Hard stops. It's fine. I see. Yeah. And then I think this is the Thrifty telescope. I think the Thrifty telescope is fine, but I like using, if you're running like, if you're not using the springs, I would rather use the West Coast Products one because it's a little bit more compact. I think I used the Andy Mark 1 or something like that, but it's like, I think the West Coast Products one has the bearings in the back, which makes it a little bit smoother. But I think the 30-bot one also just works. So if you're fine with the friction and it all works, then yeah, it's not. Yeah, it doesn't have bearings in the bottom, which is the main issue. Yeah. Once again, yeah. CAD your fasteners. I will go. That doesn't line up. Okay. Yeah, CAD your fasteners and pay attention to whatever this is. The bag motor setup is fine. I would have probably 3D printed your pulleys here instead of running the full pulleys. With the inserts, it's a little bit cheaper and it's fast, but this is also fine. Oh, you did 3D print on final. Cool. Yeah, just make sure you CAD that in. Why should you CAD fasteners? So the main thing with fasteners, right? It's like, okay, if you have anything that's moving, especially, there's a chance that you have like interferences. So you should CAD fasteners basically wherever. I guess one reason why it's good is because you can know what fasteners you need in the first place. And if you're using a specialty fastener, then it's like you can order that because you know that you don't have that in stock. Another reason why is mostly interferences. So if there's because the fastener has some amount of like size to it. It's not 0 inches. So if you don't CAD them and say your fastener is no clipping with your box tube, then that fastener doesn't actually work. And if that fastener is vital for the whole robot to work, then that's a problem. So just making sure you have clearances for your fasteners. And yeah, it doesn't take that long. If you use the replicate tool on Onshape, it's really fast. And yeah. Oh, I forgot to add music. I should add music. Okay. 1 second. Okay. We now have music. Another thing is this plate is really thick. And I'm not sure what material you're using. If it's aluminum, it's going to be really heavy. And it's a little bit unnecessary. For direction swap, I think I used Delrin and it worked. If you do aluminum, just make sure you pocket it. And you don't need to have these bearing hats everywhere. Oh, you used poly, but you didn't change the density. I see. I mean, the bearing's probably retained here, so it's fine. It's just a little bit odd to do inner bearings. I usually always go outer. So we have... I mean, the power transmission's fine. It probably worked. I don't really have anything to say. I probably would have used a smaller gear here. 28's prefer. I like 28 tooth, and you don't need to have. So if you have like bearings, if you have like gears or something on the end, you don't need the bearing hat spammed like here. I mean, yeah, it retains the bearing, but it's like it won't actually do that much, I think. You don't need it, but if you wanted to add it, then it's fine. And I would do smaller gears here. So like 28's good. I'm pretty sure 26 is the smallest, but someone correct me if I'm wrong. 28, I like 28 because it gives you a little bit more material. But yeah, these gears are a little bit oversized and that adds a little bit more excess weight. Pulleys are fine. If you do 3D printed, just make sure that you actually put in 3D printed pulleys because 3D printed pulleys will be slightly different sized than actual pulleys, like the metal ones. Especially if you use the MKCAD ones. I assume you have hex bearings in stock. If you use hex bearings, use the hex bearings in CAD. If you're using Thunder Hex, make sure you use Thunder Hex bearings. I would prefer that you use Thunder Hex bearings or rounded hex bearings, but it's fine. Let's see what else we have. All hex bearings, I see. Cool. I found the hex bearings are actually a little bit easier. Sometimes the Thunder Hex bearings are a little bit small. Yeah, I see it. There's a lot of patterns here, but that's okay. Small as 16, I see. Yeah, it's fine. I can look at it I can look at the CAD some other time. So we already went over the dead axle. Use bushings, retain it, use a normal setup. I have my arm guide will be my arm guide's in the resources channel, so you can find it there. I won't go over it too much. I won't like talk about this too much because I think you know the issues already. And I would probably not do this random step here. For the max planetaries, you don't need to have the whole plate thing on the side. But I see why you would do it because that does mount it. You can just mount it on the front, but it might be annoying to drill and access, so this might be better actually. Yeah. Just make sure that the max planetaries are hooked up together in some way, shape, or form. I think this technically hooks them up together, so you're fine here. I have no clue how this works. What? You bent those? I have no clue how this works. I see. Like bent sheet metal? I see. I mean, if it works, it works. Just make sure you show the bend in... Oh, you're gonna get dinner? Alright, cool. See ya then. Yeah, just make sure you show bends, show... Basically, if the CAD were to, like, exist in real life, and you copied it exactly, it would work in real life. That is the goal of your CAD here. Besides electronics, most people don't CAD all your electronics, and that's fine. But you CAD'd most of your electronics, so good for you. Something that I will bother you about is your origin is placed in Narnia. Don't do this. Make sure your origin is at like a normal location. So like down here. I need to get Epic Pen. But yeah, and then that allows you to do like a proper master sketch setup. I assume you don't do that in this CAD, but I can look at the other CAD and we can see. So not in the spot, I see. What else can we find here? How is this battery mounting? I see it also clips with the RSL. I mean, if the battery mounting works, it works, but RSL is broken. I see. Big RSL, the real ones on the side. Oh, I see it. Is there a simplified model for the radio power module? Ah, okay, cool. Yeah, I would use simplified models if you can. If it doesn't exist, I'll make Andrew make it. Yeah. Over here, I would probably make this a singular plate, unless you have a reason for making it 2 plates, like manufacturing size. And then, yeah. Oh, something that's cool is for if you need to have standoffs like this, right? And it's 14 inches. Actually, 14 might be a little bit too big. But if you go to like, is it? Nope. Let's see if we can buy it. So if we go to West Coast Products and we go to like aluminum standoffs here, what you can do is you can get the 8-inch standoff, or like basically just take a standoff and then match it with spacers like here. And I think the largest size you have is what, like, I think that's 3 inches, right? So you put them on each side, and that's like 14 inches max. You can have that COTS as a standoff that's pre-threaded, and that means that you can basically just buy your standoffs and your standoffs. And it's a little bit overkill, but it's way faster to do. And I use it a ton in my CAD as well, because it's just super easy. But it's one of those tricks that you can do to just increase, if you can't manufacture standoffs or you need to save time because you don't have a lathe or whatever, then that is how you do it. What else do we have here? I think that's... It would be nice if you could use these outer holes instead of the inner one, as like it's a little bit stronger if you put the bolts on the outside. But if it works, it works. Yeah. Is this thick wall? That is thick wall. Okay. Don't use thick wall. Use thin wall here. It's gonna be a little bit too heavy. But all thick wall? Okay. I see. Yeah. Just buy the max tube. I think you already know. Oh, that's rough. That sounds like a pain to manufacture. Yeah, don't if you're not buying pattern tube, don't like pattern it in CAD because that sounds like a pain. Yeah, the West Coast Products stuff is good. And then I'm not sure if this actually does anything. Because if this all connects, then you don't need to have this plate, so yeah. Oh, bean breaker? I see. Yeah. It's just a lot of just simplifying stuff. Like, I think the main takeaways here is CAD fasteners, simplify your CAD, make sure you like instead of using like welds here, just use gussets or whatever. Try to avoid spamming like short shafts that you have to manufacture because these are really hard to tolerance, right? Just do that, use a normal dead axle, master sketch everything. And then, yeah, I'd gusset here as well. And then CAD your gussets as well, if you're doing gusset. And then, that's kind of it. I would actually make these gussets a lot bigger. These are 1/8, but it doesn't matter. Just make them, I would have made them a lot bigger here. Or done like I think these are 1/4 inch, but I do 1/8 and just make them fat. These fat gussets are usually strong. But yeah, I don't have anything else to say. Use a master sketch. Try to avoid welding and use pattern tube, and I know you're gonna use pattern tube, so yeah. And that's kind of it. Well, I guess we'll just move on to the next one. I guess for example, before I move on, this is what I did for my arm. So you have max spline, and then the bushing is riding on this dead axle tube, and then the arm rides on all of that. And then we have our encoder set up right here. That's 1-to-1 by using this giant pulley. It won quality award for that? No way. I won't judge, but I'll judge the judges, I guess. If you get Call Word, then I guess congratulations. I see, I see. But yeah. And then make sure you CAD things as if you would use them in real life. That's the main thing. Oh, I would probably bolt and washer this. I wouldn't use shaft colors here. That probably added to the weight as well. I see. Alright, let's look at this CAD now. Do you have any other questions before I move on, or? Oh, that's it? Cool. Let me check if there's a stream review request. Alright, let's move on to +1. Okay. So this one, let's see, origin. Yeah, I mean, origin's on floor, so that's good. Is it centered on this axis? Yes, it is. That's good here. Just make sure it's on the center of the robot for this side. This is a little bit awkward to have it. Yeah. But otherwise, it's fine. If your master sketch represents that properly, then we're okay here. And let's see if the origin is represented properly. Nope, okay. And if this is the center, make sure your origin's in center. I'm not sure how this happened, but I can't access any of the other documents, so I'm just working with this. We talked about it a little bit already, actually, but yeah, the vector intake wheels didn't work. And it was just they just don't work on cubes. Make sure you prototype it. But generally in FRC, vector intake wheels don't actually work. So it's best practice if you want to, like, I mean, there's exceptions. Like 2910 has their giant vector intake wheels, and that works for 2022. But like, for most teams, just a full over the bumper intake is just so much easier. And you just index inside of the robot instead of outside of the robot. And that keeps it touching on as well. So, yeah. But I already talked with the person. And yeah, these didn't work. It's whatever. Let's see what else we can look at. The tube standoffs are fine here. I don't really have anything against the tube standoffs. Though this size is a little bit weird, so it might be annoying to manufacture the tubes. Let's see. Yeah, just really tight packaging here. Like on the linkage and everything. I assume it's just due to the nature of your architecture and you can't really do anything about it. Let's see. I think the one thing though is if you can start CADing with like, oh yeah, you could probably not use tube standoffs here and use like COTS right here. I would use COTS here. And then here, I would also use COTS. So like all of these like standoffs, you could probably use COTS, and that should save a little bit of time, or a large amount of time actually, because each of these take like, I don't know, 5 minutes. So what, that's 20 minutes, another like 15, 35 minutes, probably an hour worth of manufacturing saved if you use COTS. I mean, this shaft, are you using, I can't ask questions, it's whatever. But if you're using Hex, then use Hex. If you're using Thunder Hex, make sure you use Thunder Hex here in CAD. But generally Thunder Hex is popular for a reason, so yeah. So this is Thunder Hex here, so I think you have Thunder Hex. I'm not sure why it's Hex, but I won't think about it too hard. Over here, custom setup for custom reduction for the indexer. I mean, this robot worked in real life, so I assume it works. They have tighter tolerances? Yeah, that's true. Yeah, sometimes they jam and Thunder Hex is annoying because of that. Like, the Thunder Hex won't fit in the bearing. Let's see. I mean, the wheels are fine. I don't think you need all three. You could probably get away with 2 here. But that's like very minor. Yeah. Fasteners are catted, so that's good. I would have probably catted the fasteners here because unless this is probably rivets actually, so you don't need to. This is certainly a dead axle setup for the for the pivot. I mean, if it works, it works. I don't think there's a. I would have probably used a shoulder bolt here instead. It's a little bit simpler. But yeah, it's like, I mean, if it works, but it just looks really annoying to make. And for quality of life, you want mech's life to be as easy as possible. So a shoulder bolt setup with bushings is really easy. I've done like literally a 1032 bolt with a aluminum spacer, and that works as well. Just I would simplify this and make it a little bit easier. If this is actually really easy to make and I'm just wrong, then just do that instead. Because the goal here is we just want to make life really easy for your build team. Over here, I think he used. What is this? Oh, I think it's just a shoulder bolt with spacer. Yeah. I mean, this works as well. I mean, yeah, if it works, it works. I don't have anything to say, but. And it's good, but make sure you standardize it in the back as well. What material are those spacers? I have no clue. Can I measure? Mass properties. Probably 3D printed. Oh, it's Onyx? I see. Yeah, I would have used a COT setup if you could. If you can just 3D print Onyx, then it works. Let's see. 3D good use on the 3D printed. I would make sure, even if it's Onyx, I would probably use inserts here. Just inserts everywhere. I'm not sure how. I don't know if Onyx has issues of rounding out, but whenever you use 3D printed pulleys, I like just putting inserts for it. I guess moving on from the intake, I'm gonna delete the bumpers actually. I don't want to look at that. That sounds annoying. Max swerve is fine. I don't have anything to say here. Oh, you have pneumatics here? Wait, what are the pneumatics for? Oh, it's for the intake, right? The pinion broke? Wait, which pinion? Do the plates on the top of the intake pinions, I see. How did they break? I won't think about it too hard. I think these these extend it. Okay. I don't actually think, do you need to have the, I see. Yeah, the top plates for bumper mounting, that's fine. Do you need the swerve corners for extension though? Because usually you do the swerve corners for if you're mounting plates on the side. I see. Yeah, if you don't mount any plates on the side, I don't see a reason to extend the frame perimeter. But it's also fine. Oh, you did other stuff? I see. What else is here? I assume this is all riveted, so I won't bother too much about that. Let's see. Does arm linkage work? Okay, arm linkage works. I can look at it like this. Let's see. So we have max planetary going in. max plan, the shaft clips, make sure you just CAD a custom shaft for this. There's an option in MKCAD to do that as well. So make sure you do that. This is probably a perfect scenario where you use COTS, like a COT spacer here instead, because this looks so painful to manufacture everything. Make sure you use COTS there. And then the retention's good. Yep. Oh shoot, my bad. Thank you. 112. 112. And then I see you're using Thunder Hex bearings here, so make master spacers. Oh, okay, that works then. That's good. That's good. Cool. Yeah, they're threaded. Okay, cool. You could probably just use instead of the threaded ones, you could probably use unthreaded ones here. Like the unthreaded and just go through bolt for that. It might be easier. This shaft does not line up. I won't think. Huh? Did you have any issues with this? I mean, it lines up back here. This doesn't line up, but it worked? No way. Okay. I won't think about it. That shouldn't work though. Just make sure in CAD, make sure it actually doesn't no clip like this. But if it works in real life, then I won't complain about it. But for like designers looking at it, like actually make sure you. If there's like no clipping, then obviously you need to fix it. It differs from reality. I see. Yeah. And then CAD your bolts here as well. Always CAD your bolts. Let's see. CAD your retention. Make sure you do that. That's always good. Make sure you CAD your shaft retention. Over here. Yeah, basically make sure you CAD your bolts. Like this area is so tight that I would CAD my bolts here and my shaft retention. Otherwise, you might like something might hit because it's really tight. It probably didn't hit because you already built it, but moving forward, you should probably make sure you do that. Let's see. It did scrape, yeah. That's expected. I guess we can look at ARM for a little bit. So if we look at ARM here, it would have been nice if we used 2 Neos instead of 1, like 2 motors on this. I'm not the biggest fan of using a singular motor here, but I'm not sure how well it worked for you. I assume it worked. I just like, if you have 2 motors, it's a little bit easier for programming as well. If you just overpower it, it makes it speedier. But this goes up. This is fine. This is all 3D printed? Why not? Oh, it's 50% speed? Okay, then you're fine then, yeah. I wasn't sure how heavy the arm was. If it works, it works. I usually go really conservative on arms though. Good use for access. Not the biggest fan of using a hex for this pivot right here. Yeah, I mean, it probably worked for you. But I think, you know, my stance, I prefer it dead axle. I think the lever is small here, assuming that the bearing is... There's like very little lever, but I'm not a fan of having the hex here. And since it's dead, it should be fine. But I think I already talked about it in the first one. Make sure if you can use a dead axle, but if you have the like a dead axle with a big tube, but if you have to use hex, then it's probably. But these are the max spline rockets. So I think you could have gotten away with using a max spline here if you wanted to. Because if you have the max spline sprocket, you should be able to have... Actually, no, you'd have to have it on the other side. Did he... Yeah, use max spline sprockets, but it's all hex, so... That's true, that's true. I mean, let me think about that. Drop the playlist, it's fire. I'll drop it later. I don't think the hex is is the hex transferring any... Oh, I guess it is transferring the torque. Or is it? Okay, I won't think about it too hard. But if it works, it works. I think there's a way to dead axle with a big tube here. This is technically... I think this is technically dead axle because you have the things going through. But, yeah. Yeah, it's just a really, really long song, actually. Yeah, zombie. Make sure you have bolt holes for this. I'm kind of curious on how you attach this, but that's whatever. CAD bolts here. That's... I mean, you already know that, though. Oh, you did use max spline here, though. Attached with hopes and prayers. Oh, Velcro? Oh, you didn't use it. I see. Is this a hard stop right here? Like this thingy right here? I guess while we're at it, I'm kind of curious. Did you have any issues with this? Because generally with thinner hex and if it's a 3D printed pulley, a lot of the time it'll just round out really easily. With the pulley, it's just tiny, so I tend to stay away from using tiny pulleys. Like I go minimum 24 tooth. But I haven't had that much experience of Onyx, so I can't like give a definite opinion. So I'm trying to figure out how this works. Oh, it's pneumatics on the bottom. Let's see. I'll bug you again about shaft retention. Make sure you CAD it in. I've probably repeated it like 12 times already. What else is here? Good use on the crush block here. I like that. Okay. That's fine. You see, I'm at this stage where I'm just kind of looking around for stuff. There's no bolts in here. I mean, I assume you did it in real life, though. This is like one of the areas where I definitely would have catted the bolts, though. Does this stack work? I think the stack works, it's fine. Make sure you put spacers here, by the way. I mean, there's nothing majorly wrong with the design, though, so that's the good thing. Yeah, I would have avoided using bent sheet metal here, just because it's annoying to do. But if you can do it in-house and it's not awful, then it's fine. But yeah, that's kind of it. There wasn't like too many things, I think. It was overall pretty decent. Just the main things is make sure you CAD your shaft retention, make sure you CAD your fasteners. I'd be a little bit more aggressive on cost usage, just to save time on manufacturing. And then I would do that. If you have to use these things here, then it's fine, but try to use more COTS if you can, just to make it easier to assemble. Just keep it in one ecosystem. And that's it, I think. I don't have anything much else to say. Do you have any questions, or? Alright, I guess we'll just move on to the next one. Is Andrew here? Cool. Actually, we'll do the 6036 robot. 1 second. Let's get it pulled up. One second. V93? I think this is it. So this is 6036's robot. And then afterwards, we'll do 6657's robot. And then 1757's robot. So this one's CAD Infusion, so I can't say anything about the on-shape practices. This is imported. Oh shoot, 1 second. But as we wait for it to load, we can take a look. I mean, 6036, their robot was really good this year, so I don't think there's going to be major issues. But I'm going to nitpick because why not? I guess we wait for Onshape to do its thing, and then we can go from there. Okay, let's see if I can do any major things I can catch immediately. Make sure you CAD your belts, by the way. I'll bother. CAD your belts. It makes it easy to order, and you'll figure out. And that way you catch any issues. So CAD your belts here, same right here. I don't know if Fusion has any tools to make it easy, so if it's actually a pain in the butt, then maybe not, but I would CAD your belts here. This gear reduction seems a little bit overkill. You could probably save some weight by just doing your whole belt, by doing like a belt reduction instead. I'm not, because you're running a Falcon to a small gear to a big gear. And also make sure you CAD your shaft retention here. That's important. And then you're going to this really tiny pulley to another tiny pulley. Like if you did like a tiny pulley to like a really big pulley here, you can do probably a 3-to-1 reduction. And then you can probably that makes it a little bit easier. And then you can print these pulleys as well and add inserts. And that should save you a bunch of weight if you're going for weight savings. I think this was polycarbonate. I don't remember. I assume it's polycarbonate though. Use of spacers is fine. Yeah, there's spacers in between, so that's fine. I mean, intake's fine regardless. It'll work. And I mean, the robot's good, so I'm not gonna say anything that's not gonna like not work, but it works. Let's see, we can get an intake then. Alright, I'm gonna nuke the bumpers real quick. This is my first time actually looking at the CAD, so I'll also be enjoying the CAD in the process. So let's see. So we have Falcon here, single Falcon. And then we're running it across. This is probably a bunch of unnecessary material. But I also understand that it's easier just to copy the plate. So I won't bother too much about it. But you could probably save some material and money and weight by just doing a smaller plate here. I see why you'd copy it, so it's not like the most major of issues. I am not going to bother calculating center to center distances. Make sure you CAD your shaft retention, by the way. Let's see, gear here. And then, okay, good. Good use on the torque transfer. Shaft here, that's good. We have... I mean, this is probably fine. I'm not sure how much a reduction is. It looks fine, though. In theory, I would like a larger sprocket, but it probably works. So I'm not going to complain too much about it. I think this is dead axle. Yeah, it works. I would use a bushing here instead of a bearing, just to make it a little bit stronger. This whole setup's dead axle, right? Yeah. I would have probably done a hex dead axle just to standardize, because like, I mean, this is fine. Like the 3/8 tube is fine. The 3/8 standoff is fine. Like it'll work. But I think if you standardize on half-inch hex, like rounded hex here instead, and I like there's setups for it as well, it'll make it a little bit easier in case, like, that way you don't have to order anything else or cut anything like new. Falcon Guard's cool. I don't know if you need this though. I mean, I see why it exists though. And then it's a reduction. I mean, it works. I don't have anything to say. Yeah, then this outer plate keeps it strong. Good stuff. I would have probably added actually, no, I wouldn't. No. Would I need it? Actually, you're probably fine without it. No. Okay. Yeah, main thing is just make sure you CAD your bolts here. It's annoying, but it's important. Oh, is this a tensioner? Huh, I see. I guess you can do the sprocket tensioner. I would rather you use a inline tensioner here instead. But if you made it work, then sure. But I would rather use an inline tensioner here. Let's see. Let's get the pivot. Actually, that's probably that's the fun stuff. Okay, so we have hex goes across. Let's see where does it start? Okay, we have 2 falcons here, and then 2 falcons down here, and then one of the falcons is gonna power the top pivot, which this pivot is dead axle. That's good. And then good resting the whole thing. Like, this is really strong. So I like this design. Not sure how to feel about using a bearing here, but if you're using a bearing, then they'll probably work as long as the bearing is big. I would use a bushing here as well. I'd use a bushing. But the bearing probably works, so I won't complain too much about it. Let's see. And this goes through. I might be a little bit worried about... So if it's attached, if your thing is attached over here, right? I don't think you need bearings going through the center, because that might over constrain it. and that might make it tight. So I would probably not have the bushings here. But yeah, I probably wouldn't have had the bushings in the center just to not over constrain it, I think. Because I think it's plenty strong just on the outside. But I might have looked at it wrong. And then just had the bushings on the outside and you should be fine there. Let's see. We have chain reduction. My on-chip is laggy. And then this goes here. And then 1 second. How's this sprocket powered? Once. Oh, it's the spacer through. I see. I mean, it works. I would make sure I would have probably drilled this out to 0.196 just to make it a little bit stronger. Yeah, I would have drilled it out and made it, and then that would have made it a little bit stronger because 832 is so weak. It's not great for high loads. That's the one thing I would have probably done. And then once again, I would have used bushings instead of bearings. But if the bearings work because they're big, then it's fine. But I'd rather use bushings here. What else do we have? I'm just looking at the power transmission. If I can read it. 2 Falcons going into this gear. That goes through. Here goes here. It goes up. I mean, the custom gearbox is fine. We've also hit a point in like FRC where you can probably get away with max planetaries nowadays, and that simplifies the process a lot. Like if you look at Citrus CAD, like this year they use max planetaries, which is crazy, but yeah. But you get a lot less backlash of a custom gearbox, so I get why you'd use one as well. I'm not sure why you have the hex shaft go all the way across. I'd be a little bit worried about over constraining because you have a bearing here, then a bearing here, then a bearing here, right? So I would have deleted the bearing right here, I think, yeah. And that would mean that it would not be over constrained then. And then you do the same on the other side if you're doing it the same on the other side, but make sure you only have 2 bearings on a shaft. Or if you have more than, or like, you can, there's exceptions to the rule, so if you have like something that's floating on the shaft that has 2 bearings on it, then it's fine. But generally you want to try to only have 2 bearings on a shaft just to avoid over constraining, because that makes the shaft that just makes life hard, because it adds a bunch of friction and whatnot. CAD shaft retention, once again, I don't have, yeah, I've said it like a bunch of times, and I've said it in all the other reviews. Just make sure you CAD shaft retention. I think you have access because of the pocketing. Let's see. You probably have access. It just sounds really annoying to maintain. But if you can make it work, you can make it work. I see, this is the tensioning solution. I guess that works as well. If you don't have enough room for a turnbuckle, then you can do that. Please CAD fasteners, holy shoot. I don't think Citrus CADs their fasteners, but I would judge Citrus about their lack of fasteners as well. What else do we have here? I mean, good use on the bent sheet metal. I don't have anything. I think that's mostly it though. I mean, it's a good robot. I'm pretty sure it was like top 10 in the world, so it's not like there's gonna be like a bunch of mistakes. It's mostly quality of life. Oh, I would put grommets here. Put rubber grommets here. Maybe you've done it in real life. If you did it in real life, make sure you add CAD. Make sure you do that. Because metal is sharp, and that is not... And wire does not like sharp metal. But yeah, that's kind of it. Oh, I guess over here... Once again, I'm not a fan... I mean, tube spacers are actually great. Like, I'm not gonna, like, completely judge tube spacers. But always try to find, if you can, just run COTS instead. Because that'll save a bunch of time. But I think that's it. Yeah, I would probably use COTS here. And I'm kind of curious on how you're running this. Oh, I see. So you're running a long bolt. It goes across, and then it goes into the tube spacer in here. Yeah, that works. Like usual, I'm gonna say that if you have spacers here, you can probably use a COT spacer and be fine. But the big diameter of the tube is good because it's very strong. So it's not like... It's a trade-off, right? You're gonna save time, but it's not gonna be a tube. But it also means that your life is gonna be a lot easier. Oh, sorry, one second. Alright, I think that's it. Just make sure you cut all your fasteners. Big grommets here. And then there was some other stuff I was talking about. I completely forgot. Oh yeah, make sure... You could probably lighten this whole thing and use a lot less gears on this side. And then make sure you don't over-constrain your shafts, because I see that a lot. Yeah, I mean, you can get away with it, but it makes it annoying to assemble, so... I think that's it. I don't have anything else to say. I mean, it's a good robot, and the CAD's good, so... Not like I can complain. But yeah, that's it. Let's see, what's the next one? I did not even change the CAD status, holy shit. Oh well, just assume that the CAD status is not accurate. 6657. Actually, I want to wait for Andrew to come back. We'll do 1757 first. Yeah. Here, where is it? In main. Okay, now we wait for it to load. And then I will change the number to... I think this is 1757? Cool. Yeah, so we can look at this bot now. Big tube. Double jointed arm. Very cool robot. I guess we can just start. I'm gonna hide these parts. Not a fan of the 80-20. I'll just say that flat. There's a significantly lighter way to do this. That's not 80-20 for your standoffs. For the polycarbonate, like even like 1x1 with 2 plugs probably is lighter. And I think this is also clipping with a bunch of stuff. Yeah. Make sure it doesn't clip. I'll catch that first. Can I hide the bumpers? Oh, you don't need to cut your noodles. Oh, yes, it's for the bumper mounting. Citrus style, that's good. I guess we can look at the arm. So we're using the COTS arm gearboxes, which is fine. I'm not a fan of using them versaplanetaries for arm reductions, but if it works, it works. Like, you'll add more backlash, and that might be pain. One thing I would do is make sure you hook up the 2 shafts. So instead of having a singular shaft, have them actually wait. No. Okay, wait 1 second. Okay. Before I end up reading the CAD wrong, 1 second. Let me read it correctly. Oh, is this using? Oh, I see. I don't want to change the configuration. So this goes here. But then this impacts the actual pivot, right? Okay, I think this is pivot. Good use on the dead axle though. And it's quarter 20, so it's drilled out. That's good. I mean, if the sliding gearbox works, then it works. Does that use the versaplanetary stage on the end? That's odd. Or did you add that? I would probably... If you had to use the versaplanetary stage, then sure. I mean, it probably works. I would have used... Actually, if this is all tube... Yeah, that's all CF tube. That's not going to be that heavy. And then the through bore. Here... That's the closest you're going to get, so that makes sense why you're putting your through bore here. I would probably use rounded hex instead of hex, and then make sure you add shaft retention here. I think you use shaft collars, and if it works, it's fine. But not a fan. So I personally don't use COTS gearboxes, so... I mean, I use, like, max planetaries, but I don't like these big assemblies. But if it works, it works. And this is probably the right use case for it as well, so... So we go from this to here. Yeah, actually, looking back, if this is powering the second joint, then I would make sure that... This is... Oh, wait, is that... No, that's powering the... I'm going to... Okay. No, that's powering the wrist. Okay, that makes sense. That's why they're not hooked up. Okay, cool. I see. And maybe there's a... But then if this is hooked up, then you're good. So, assuming there's a Falcon on the other side. And if there isn't a Falcon on the other side and you're just doing it single, then it's fine. It would have been nice if you had a second Falcon here. But I see why you wouldn't use it. Use a singular one's probably going to power it fine. Good use on a dead axle here. This is... Let's see. Needle bearing. I mean, since it's really big, then I'll say this is fine. I would have probably simplified the model in some way, shape, or form, because this is a really high detail, and you don't need high detail here. But, yeah. If this is 30... This might be actually a little bit overkill if it's 35. I can't tell if it's 35 or 25 chain. See if I can find it. It doesn't say. Is this custom? And then max spline here. Max spline's fine. This is clipping though. Make sure you fix that. Ooh, I would probably make sure. So I don't know if you had the polycarbonate plate on here or not. Does this actually exist? I have no clue. If it did exist, I'd probably put standoffs here to hold it in place and keep it rigid. And then I would probably do like a thick quarter poly instead of the aluminum, or like a thin aluminum with a quarter thick poly here, I think, in case it rams into something. So this intake looks kind of incomplete, so I assume that it was done in real life, or this is not the updated CAD. I'm not sure which one it is. Yeah, this is not like done at all. Like I would make sure that this is done, so I don't have anything else to say besides make it complete CAD, I guess. I mean the robot worked in person, right? So it's not like this will. I think you already know about this. CAD practices wise, let's see. Multi-dock, where's origin? Origin's on floor centered. Yep, that's good. I do want to go into the arm. Okay. But main looks fine. I think the main optimizations is probably just not use this 80-20 here. There's probably better ways to pocket the belly pan, but it's fine how it is. And then yeah, it's just a bunch of minor stuff, I think. But I mean, it's fine. But let's see arm. This is what I'm kind of curious about. Parts, multi-body. Everything's named, so that's good. I do need to see it in order to. "81 versions. Master Sketch. This is Master Sketch. Oh, that's actually pretty good. Huh. So 300 features is a lot. Yeah, I'm not gonna read into all the features. Organization's fine though. That's good. It's a lot of custom parts, so I'll just give like my context. I don't usually use this much custom, but for like a joint like this is good design, so I can't really say anything. Location's good, everything's fine. And it's all multi-bot. And the location of the parts is good too. Yeah, I mean everything besides the intake. Like the whole arm joint is really good, and since it's just the arm plus the end effector, like I can't really say like that much. It's good CAD, so yeah. I should probably read the actual request. Oh, use the main. Oh, I see. The other stuff was. Oh. Yeah. The main things is make sure I'd probably make this custom instead of using the funny. Oh, I see. It was Perdo. Alright, let me find it. Oh, is this the intake? Okay, this makes a lot more sense now. Okay, cool. Okay. I was like, why is that so broken? Okay. Okay, main thing here. Yeah, I mean it is overbuilt. By a lot. Main thing here. Like, what are the goals of this? Are you trying to save weight, or are you trying to... Okay, I would probably use a Neo here instead of Neo 550, but I think Neo 550 works, so I can't really complain. And then I would have 3D printed this instead of using this like corner bracket. use Thunder Hex instead of Hex, but if you have Hex in stock, then I assume that's why you're using Hex bearings. So you don't need this retention. I don't think that does anything, actually. Like, I don't think you need these plates, and you can drop your part count by a lot. Are these... Yeah, you don't need that either. Oh, it ended. I'm gonna replay it now. Alright. What else do we have here? I don't have anything else to say. It's fine. It's just really overbuilt. I would probably use a Neo here. CAD your belts. That's important. Otherwise, and I don't think this pulley does anything. Or it might have actually done something. This goes here. I know it does something. Yeah, this gear is massive. You don't need to do that. That's heavy and annoying. But yeah, that's kind of it. I don't know. That's for. Is there parts? Okay, this is the parts for the factory build. Yeah. Good. If this is contextual, so if you aren't using this, actually no, you do use this. Okay, and then does the arm use this or not? Okay, that's good. That's no do parts. Okay. So let's check origin real quick. Uses a master sketch, so that's good as well. But yeah, I don't know. Like, I can't say much. It's like it's fine. It works. If the robot works, then it's good. The main concern that I have is since it's very, like, even though it's well designed, it might be really annoying to, like, manufacture everything since there's a lot of custom stuff. So it'd be nice if it was a little bit, like, less manufacturing reliant. Because it just might take longer to build. So just for speed. But, like, I see you did make the trade-off, so, like, this is one way that you can reduce the manufacturing time by using COTS. But this is also, like, the one area where I would probably go custom, because this is funky. I mean, yeah, since this is the only, like, sub-assembly, if you want to go full custom, then sure. Yeah, I don't have anything else to say. I want to see if Andrew has his robot. But yeah, that's kind of it. Yeah, I mean, the better robots are going to be a lot easier to, like, to review. Like, there isn't, like, anything for me to, like, specifically say. Like, it's mostly just quality of life, I think. If you want to go and get it, like... If you want to get something reviewed, just put it inside of the Discord server and I'll check it out. And just request that you put it on stream as well. But, like... This robot's good. Besides the, like, this custom gearbox thing, which I mean this COTS gearbox thing, which I would have went custom. I don't have anything to say because I don't have as much experience doing these giant dead axles. So that's kind of it. Cool. I'm just gonna go through 6657s, and then I'm gonna end the stream after that. Because I think that was a little bit awkward just to kind of review and just be like, oh yeah, this is all good. But sometimes CAD reviews are like that, especially with finished robots, because when the robot's already done, right, and it's built, it's like, usually you'll catch all the issues while you're building the robot, and then you can fix it in CAD, right? It's like, yeah. But I mean, with that robot specifically, the CAD practices were like really good. And I might look into it again to see if there's anything I can learn from it, but it's not like there's not like any major issues that would have messed things up. And I mean, yeah. Alright, let's go look at 6657s. This one's for Madtown Throwdown. Take a look. This uses Churro. I would go Cots here. It's just, the distance is so short, right? So it's like, I think my general rule of thumb is if it's larger than like 3 inches, then I would do a standoff or a threaded standoff. But if it's short like this, then it's a little bit more annoying. And I would probably go spacers instead, like 3D printed spacers, or a COT standoff. So it's your choice. I think if you're low resource, I would run 3D printed though. Because 3D printed will be a lot faster to... It takes longer to manufacture since it's overnight, but it'll be like the exact size, and that'll be a lot easier. Let's see. Pulley goes here. There's not much of a reduction on here, so I would be a little bit worried about the speed being a little bit too fast. It'd be nice if you could 3D print and make this pulley a little bit larger, if you could. And if you can't, then it's fine. I'd just be a little bit worried about cones, I think. And taking cones. 22 teeth. Does this have inserts in it? Make sure you add inserts. Yeah. Inserts are important here. And if you're catting them, make sure you cat it and it has the inserts catted in as well. Or just like the actual hub for the insert. So you don't need to actually cat the insert, you just need to cat the hub for it. And then yeah, I would just do a through bolt and then not use these hex heads. That's kind of it. The one thing is, if you aren't using the shaft retention screws, I would not CAD the shaft retention screws and do a bolt washer. Because, this actually, like, punished me in the past, actually. But these are, like, this shaft retention is really thin. And if you run, like, a bolt and a washer, like a socket head, it's, like, 1/4 inch or bigger. And for clearance-wise, you want to make sure that you aren't gonna get, like, punished by clearances because you used the wrong sized bolt in CAD. So just a heads up for that. I think this is fine. Use the through bolt here. I'm kind of surprised on why I used this bolt though. But yeah, I usually would just go off. I would standardize off churros and just use COT spacers for that. The West Coast product stuff is so good. And then same here, I would use COTs instead of custom, or I would do a spacer then do a long through bolt. But I think COTs is fine, or I would use like 2 of these and call it good. I don't know, this might be a... You could also do a tube here, actually. Actually, it's 2.5, I'm not sure. You get a tube with like 2 tube plugs and then bolt it in, and that's it. That would work as well. Or just a really long bolt that goes through. I think a long bolt actually might be really good, but... If you need to have the button heads for clearance, right? Because the clearance here... Probably a tube is a little bit simpler with less parts. But you could definitely drop the part count here. I don't have anything to say about the plate carriage. I mean, it works. It's just really heavy on manufacturing, right? Because it's all custom, like, plate and stuff. But if it works, it works. All the fasteners are catted, so that's good. Let's see. There's a slot here that goes on the outside, so that's fine. That's a 1032 tap, right? So we should be good. Actually, okay. I would make sure to put crush blocks here. That's important. Put crush blocks so that you don't accidentally bend the tube when you're assembling it. If you put like a tiny flange on top of the crush block, then it won't fall through. So that's good. So just make sure you do that. Crush blocks are great. Just it's like a 3D printed thing that fits inside of the tube. Let's see. Same here. Make sure you do crush blocks. Over here as well, crush block it. If you use a shaft collar, that's fine. That works. This goes through, no issues. Make sure you fillet your corners. Actually, over here too, fillet everything. It's kind of weird to have 90, like, you're not gonna machine it as like that, unless you like fab works it, but like, even so, emotionally, I would like it filleted. Let's see. Crush block the bottom. It's a simple bot as well, so it's not like... This is fine. I mean, it's a simple bot, so I can't really say anything. Hex shaft, spacer, this goes up, this will work. Add your nuts here, it's fine. Bumper mounting, if this works, it works. I would use citrus mounting, but if this bumper mounting works, then... Well, if you can center the pigeon, I think you can adjust in software as well, so I don't think it's the biggest issue. This is fine. Yeah, that's it. Main thing is to make sure you add a little bit more reduction if you can on the intake, and then I would put crush blocks everywhere. And then I would 3D print these or use COTS, just because that reduces the manufacturing steps and that saves you a bunch of time. Because each of these, if these took 5 minutes each, then it's like 1, 2, 3, 4, 5, 6. That's like an hour worth of work right here. And if you're running, like if your meetings are really valuable, like time is important, then you want to save time here. This half? Is this quarter? It's 1/8 inch. Okay. I mean, okay, 1/8 inch is probably fine. I would... Like, I think you had quarter at one point, and I think it was okay to have it quarter because it's like one part. And it's not going to be too much weight if you run quarter, but 1/8 is fine. Hide bumpers. This is fine, no interferences, everything's catted. If you can, add like mounting points for ballast. Because this might be underweight, and if it is underweight, and it's definitely underweight, just add more ballast that if when you go to the high point or your scoring position, you don't like fall over. So just like put something in the back. If you can, like you could fabrics a 1/4 inch piece steel on the back side right here and bolt it on. That would work as well. But just anything to just get a bunch of weight in the back, because right now, like it'll be fine, but just when the elevator is extended, you might have some... It'd be nice if you could stay a little bit more stable for your driver. Battery mounting is fine. Make sure you add foam. There's very little rivets on this robot, which is... Oh, I would also make sure you crush block that. Yeah. But I think that's it. I don't have anything else to say. End of the day, just make sure you use crush blocks for everything here. Spacers here, or 3D printed spacers here with a through bolt, because that reduces your manufacturing steps. I would do inserts with these pulleys so that they don't round out. Same with over here, and then increase the reduction a little bit. And then I think the elevator is fine though. There's nothing wrong with the elevator besides the crush blocks, and this is a simple robot, so yeah. That's it. I'm gonna call it good for stream. If you're interested in more streams, I'll ping the whole Discord like when I do stream, and then I'll do design reviews. So if you just submit for design review, I will, and just request that you want it on stream, then I will review it on the stream. But if you want faster review, I can just review it like... If you don't ask it for on stream, I'll just review it in text, and then I'll just really quickly spam that out, so... Yeah. Thanks for watching. Hopefully you enjoyed it. Thank you. See you later.